short video is the first in a series documenting the P3D drill and blast. The drill and blast software is a tool to lay out blast patterns, do some easy and fast 3D editing to create your pattern, and then upload them to the drill either by DRL files or CSV files. Let's take a look at the initial settings under Mine settings. This is where you first choose what type of pattern. You can do square or rectangle or staggered. I'll go with staggered, and then you set your default row and column distance, the dip angle, direction, the default hole depth, but it would go to a surface if there is one defined. Then that's the actual hole diameter, and then the display for the screen. And then the high wall tolerance is what you allow the hole to get close enough to the high wall for face interpretation. Minimum top stemming is set here. And let's look at the distance tolerance for the as drilled. So the final step in another video will be to compare the design with an as drilled, and these are your tolerances that you will allow. The other tabs allow you to just define different types of material to load the holes with, and then you can define your default hole loadings just to grab from a list. These can be predefined and saved just one time. So for example, here's a 2-deck blast hole down to 30 meters, showing you the weight in kilograms of the ANFO and the inert. The process to create a new hole loading is to come down and hit the blue plus and come up with a new name, new loading. We'll just right click, choose rename, and we'll just call this hole 3. And then you start filling the hole from the bottom up, and you simply click add material. And let's start with some ANFO at the bottom. You give it either a length or the weight of material you want to pour in. So if I put in, say, 5 meters, that calculated 25 kilograms at a hole diameter of 10 centimeters. If I increase this to, say, 15 centimeters, then that same amount, 11 kilograms, is 1 meter only. So if I switch this back to 10, then the hole is smaller. My same amount of ANFO is higher in the column. So then I add the next material, which will be some inert, and let's just put in, say, 5 meters, and then we'll come back and add another deck, add material of some ANFO, and we'll put in, this time we'll put in only 5 kilograms. 5 kilograms at that level give us only 0.44 meters height. And then we'll finally add the final step of inert all the way to the top. So don't put in the depth or weight, it automatically loads the hole all the way. So I just created a brand new hole loading. Alright, so we've got the settings, and then also if you wanted to look at your tools settings, this is where you can set up your units control. I have a default here set to metric. There's also one you can save as US feet, but this allows you to set how you want your measurements in metric. For example, the area would be square meters, or the volume of the dirt and the inert would be in cubic meters. Okay, once that's all set, then we begin by importing these surfaces. And that's done with the button at the top, Create Blast Pattern. The blast pattern needs surfaces to be created on top of, and so let's go ahead and load from a file. And I've got this blast design surface, and that is in meters. That's the top. The second surface could be another tin or grid, or it does come from an XML or straight from DXF. If you don't have the CARLSON Office software, this will import a DXF file straight. You could also go just to a flat elevation you enter in, or a depth from this existing top surface. I'll go ahead and load the bottom surface, which is another tin file. And the different colors, just because in the CARLSON Office software you can tell it what color to save the tin as, and then different textures here are applied to those surfaces in P3D. Okay, the surfaces appear, and then you'll see at the top a command line that tells you to draw or create the boundary polyline. And so we'll just take our left mouse and click and draw the perimeter of your blast pattern. Come along the back wall, and then all the way back down the face and then just hit C for close. Don't hit enter, just C only. Alright, then you'll see this yellow polyline, and this is the program's interpretation of the high wall face. So the program will actually make another surface of this to measure the hole distance from, to ensure we're not too close or too far away from this face. And it's asking us now to edit the high wall polyline, because before you want to lay these holes out, you want this high wall polyline in good shape. And these are just grips like in CAD, and you can just pick and move these to straighten it out a little bit. Or there is another option down below in the lower left. It's called Replace Polyline Section, and that allows you to straighten it out just by picking 2 points. So if I wanted to come over here and just pick a left pick here and then a left click here, that straightens out the polylines in a larger section than just one at a time. So if the rest of it looks okay, the command line up top says to press enter when done. Enter. Now you'll see a couple new polylines, one green, one blue. Alright, but now before we can pick that point, it needs a row direction. So notice up top it says pick hole row direction. And I want these holes to go parallel with this back wall. So I'm just going to pick an intersection point right here and another intersection point there. That defined the row of my blast pattern. Next, now we pick the point on the surface for the first hole. I'm going to come over here and object snap again to that intersection point. There the holes appear, and you'll see this blue type polyline that represents the Voronoi diagram. This is the area of influence around each hole, and you see the little pile of dirt around each blast hole. And if you look from the side, the holes do appear underground. And let's start by setting the texture and the transparency of this existing top surface transparent so we can see through it. So I'll highlight the blast design surface and come down to transparent and just turn it on. That way it's still there, you can see it, but at least now we can see the holes down below. And let's increase, this is your light, you can increase the intensity of brightness by moving this light source in different directions to see the holes. Now the first thing you see with these holes are the colors. And this program color codes the holes based on distance from this high wall face initially. And so the green means everything is okay. And there's two other colors you don't see. One is yellow, one is red. And if it's too close to the face, you'll have a blowout, and the holes would be colored red and yellow. So if I were to move this hole, for example, just click on it and move it too close to the face, like I'm doing here. There you can see the top of the hole is now too close. It's red and yellow. The orange and blue signifies it's too far away. So I'll put this hole back where it was, or there's Control Z is undo. But before we even try and fix up this distance from the high wall, this plan should have a angle, a dip to these holes. So let's come over here and just highlight the entire blast hole pattern and scroll down to vertical dip angle. I want to kick these over at 25 degrees to match my high wall. 25, enter. And that took care of a lot of the problems. You'll see these are now at an angle, matching the high wall face, and that there's a little bit of a problem at the bottom where they're a little bit too far away, and so what causes that is just this high wall is not a constant 25 degrees. And we've got a little issue with this one hole I moved. I didn't quite get back to the right spot. And also notice the Voronoi diagram. When I move these holes around, the Voronoi changes real time and updates. So if I move this hole, click again, the blue lines are dynamically moving, showing you the area of that blast pattern, that blast hole in the pattern. Other things you can change would be one hole at a time, or you could maybe rotate this first column. So if I wanted to go to row 1, let's highlight A1, then I'll go to row 2, and I'll hold my control button down and pick B1. Then I'll go to row 3, and I'll choose C1. Notice it's highlighted all these holes at once. And finally we do row 4, D1. Now those holes, I want a different rotation angle. So I've got those holes highlighted. I come down here and I choose a different dip direction angle. Let's go with, say, 90 degrees. Enter. And there you can see real time in 3D, those holes are now rotated at a different angle. So this is what's very powerful with this program, is it allows you to do fine tuning on the blast patterns on certain holes and see it graphically in 3D instantly as you make those changes. Now if the surface does get in your way too much, you can actually go up to the top, right click on it, and tell it not even to display. Just turn it off temporarily. That way you're looking at just the holes now, and you know the surface can always be turned on later again. And then the gray surface at the bottom, that is the blast pattern floor. Another option will be to display the blast hole names. Come over here and highlight the blast holes and scroll down into the Property Explorer, and there's a checkbox, Show Hole Text. Click that on, and there you see the dynamic text showing A1, A2, A3 is the first row, B1, B2, etc. Alright, another option is to simply add a blast hole. Let's say we do want to add one more hole here in between A1, A2. So you come over here, highlight row 1, and then right click. I'm going to add drill hole to row. Alright, so it knows we're in row A, and then you see the rubber band, and then as you left click, it's going to add a hole in between A2 and 3, and then automatically renames all the holes. So I just added a hole in between 2 and 3, and so it renamed and renumbered everything from that point on. I did show how holes can be moved, but it's also very dynamic to edit your blast boundary, the polyline boundary. And I can pick and drag this grip, move it over to the left. I want to add a few more holes. The program real time creates new blast holes to fill in your boundary. And vice versa, if you wanted to take away a few holes. Maybe I didn't need this last row of holes. I can come drag it and move it, close it off. It takes away those holes and updates the Voronoi diagram real time. So you can see it's very fast, very easy to update and edit the holes.